Hello everyone, this is our session 14 on differentiation. We have completed what are logarithmic functions and implicit functions. We're moving on to the exercise of these two functions, that is exercise 1.3. Okay, so I won't be doing all the sums. Each question, say about one or two questions of each, so that you get to know how you can solve them. So let us begin with exercise 1.3. Okay, question 1. I'm picking up the third question. So let us do the third one. Third question is y is equal to x squared plus 3 raised to 3 by 2 sine cube 2x into 2x square. Okay, so now if you observe this, we have three functions over here. 1, 2, and 3 all are in the raised to pattern. So what we'll do is we'll use logarithmic differentiation. How do we use logarithmic differentiation? So we say taking logs on both sides. Okay. Right. So this will be log of y is equal to, now log of a into b into c is addition, log of a plus log of b plus log of c. So we'll write it as log of x square plus 3 raised to 3 by 2 plus log of sine cube 2x plus log of 2 raised to x square. Okay, so how are we going to write this? Log of, so this can be written as 3 upon 2 log of x square plus 3, right, plus 3 log sine 2x. We're just removing the power, we're putting it on the or you can say before the log sign, plus x square log of 2. Okay, now what we can do is, this is a simplified form of your equation. Now we are going to do differentiate with respect to x on both sides. Differentiate with respect to x on both sides. So whenever we differentiate y, what do we write it as? Dy by dx. So log of y will be 1 upon y dy by dx is equal to, differentiating log of x square plus 3, so 3 by 2 log of something is 1 upon x square plus 3, right, and derivative of x square plus 3 is 2x. Okay, plus next one, 3 log sine 2x, that will be 3 1 upon sine 2x, right, and derivative of sine 2x is cos 2x, right, and derivative of 2x is 2, plus x square log 2. Now log 2 is a constant, so we'll write it as it is, and x square will be 2x. Okay, so what can be cancelled? This 2 over here will get cancelled. Then cos 2x upon sine 2x is cot 2x. So we can write dy by dx is equal to y multiplied by 3x upon x square plus 3 plus 6 cot 2x plus 2x log of 2. What is the last step? You have to substitute the value of y. What is y? Y is the question. So x square plus 3 raised to 3 by 2 sine cube 2x, 2x square, 2 raised to x square. So x square plus 3 raised to 3 by 2 sine cube 2x and 2 raised to x square multiplied by 3x upon x square plus 3 plus 6 cot 2x plus 2x log of 2. Okay, this is your final dy by dx. Similar pattern, you can do all the questions of exercise 1.3 question 1. Okay, just similar pattern. Taking logs on both sides, putting the powers down, and then differentiate with respect to x on both sides. Remember to take y on the other side and multiply it with the answer. Okay, let's move on to question 2 now. Question 2. We can take differentiate with respect to x. First one, x raised to e plus x raised to x plus e raised to x plus e raised to e. Okay. Now, what we can do is group the terms, right? So, or you can take direct differentiation as well. So let us say that this is y equal to x raised to e plus x raised to x plus e raised to x plus e raised to e. Okay. So if I take differentiate with respect to x, okay, please don't forget to write on both sides. Yes, what will that be? It will be dy by dx equal to, now this will be x raised to e is e x raised to e minus 1. It's similar to x raised to n. Okay. Now this x raised to x, I'm just writing it as d by dx of, okay, for now. The reason being it is a function raised to a function, that is x raised to an x function. So we don't have a formula for that. E raised to x will be e raised to x and e raised to e. It's a constant term, so plus 0. Okay. So these two are already differentiated. Now what is left is this term over here. So we consider this x raised to x as v. Okay. So if we have, we can write dy by dx is equal to e x raised to e minus 1 plus e raised to x plus dv by dx. Now I have to find out this dv by dx. How will we do it? V is equal to x raised to x, right? Taking logs on both sides, log v is x log x, right? So now differentiate with respect to x on both sides, right? So we have log of v is 1 upon v dv by dx, right? Equal to first term as it is derivative of the second plus second term as it is derivative of the first, 1 plus log x. Okay. Now this is dv by dx. So put the v on the other side. So final answer for dv by dx is x raised to x 1 plus log x. What do I have to do? Put it in the final answer. Okay, final answer of your question. So in place of dv by dx, now I will substitute this value, that is x raised to x 1 plus log x. So final answer for dy by dx is equal to x raised to e minus 1 plus e raised to x, okay, plus x raised to x 1 plus log x. dv by dx, that's correct? Yes. So we have that as our final answer. Yes, this is your first question of the part 2. Okay, let's move on to the next one. Now I'm doing all the other sums of question 2 are almost the same, but I'll do the second one for you, okay, because it's a little, you can say lengthy, not tricky, but we should know the method. So y is equal to x raised to x raised to x plus e raised to x raised to x. Let me check the question number 1 minute. So it is, yeah, it's the second one. Question 2, second one. Okay, so x raised to x raised to x plus e raised to x raised to x. We take them as different functions, u plus v. Okay, so dy by dx is equal to du by dx, right, plus dv by dx, correct? Yes, so first let us find du by dx. So we'll perform the derivative for u. U function is u is equal to x raised to x raised to x. Okay, so we'll say taking logs on both sides, log u is equal to x raised to x log x. Okay, and again we will take log. So we'll say log of log u is equal to log of two functions x raised to x log x. You know what does this mean? This is a and this is b. Log of a into b is log of a plus log of b. So it will be log of x raised to x plus log of log x. Okay, and log of log u on this side. Okay, now what is this? This is x log x plus log of log x. Okay, and we have log of log u here. Now we'll differentiate this. So differentiate with respect to x on both sides. Okay, so what are we getting log of log u as? 1 second. Yes, so what will be the derivative of this? Log of log u is 1 upon log u multiplied by 1 upon u du by dx. Okay, equal to x log x derivative, first term as it is, derivative of the second term as it is, derivative of the first. So we have 1 plus log x over here, okay, plus log of log x, so plus 1 upon log x, derivative of log x, 1 upon x, derivative of x is 1. Okay, so we have du by dx is equal to u log u, okay, bracket 1 plus log x plus 1 upon x log x. Now what is u? U is x raised to x raised to x, and log u is x raised to x log x. Let's check that. So what is u? It is x raised to x raised to x, and what is log u? X raised to x log x, bracket 1 plus log x plus 1 upon x log x. This is your du by dx. So we found out du by dx over here, right? From here du by dx is done. Now let us go find dv by dx. So what is v? E raised to x raised to x. Okay, so v is equal to e raised to x raised to x. Log v is equal to x raised to x log e. What is log e? It is 1. So we have x raised to x, right? Again, we'll take logs on both sides. So log of log v is equal to x log x. 1 upon log v. Sorry, we're differentiating. So just write that first. Differentiate with respect to x on both sides. right? So we'll have um, log of log v will be 1 upon log v into 1 upon v dv by dx equal to, what is x log x derivative? 1 plus log x. Okay, we've done this so many times now, so I'm just directly writing this. It's using multiplication rules. We get 1 plus log x. So dv by dx is equal to v log v bracket 1 plus log x. Let us substitute what is v log v. V is e raised to x and log v is x raised to x bracket 1 plus log x. So we found out du by dx, we found out dv by dx. What we have to do is substitute for dy by dx. So dy by dx, just writing that final equation again, dy by dx is equal to du by dx plus dv by dx. So let us substitute the two parts that we have. What is du by dx? Let's go and check. So du by dx, x raised to x raised to x, x raised to x log x, 1 plus log x, 1 plus x log x. So let us put it here, x raised to x raised to x, x raised to x log x, bracket 1 plus log x plus 1 upon x log x. This is your du by dx. Okay, plus sign, what is dv by dx? It is e raised to x raised to x, x raised to x, 1 plus log x. E raised to x raised to x, x raised to x, bracket 1 plus log x. Okay. So I said it is lengthy, it is not difficult. Okay. That's why I've done this for you. All the other sums have to be done in the similar manner. Now, there is one function, the third question. So I'll just show you how you will split it up with logarithms. I won't solve it till the end. You can continue the derivative later on. So y is equal to log of x raised to x, okay, minus cos of x raised to cot x. So just doing one trigonometric type so you know how you can differentiate the remaining. Again, see there are different functions, so we'll take them as u minus v, y is equal to that. So dy by dx is equal to du by dx minus dv by dx. Similar pattern. Okay, so we'll consider u first. I'll just give you the breaking up, that is how you would write them in u and v form. Okay. U is equal to log of x raised to x. So log u will be equal to x log of log x. Okay. And then you differentiate. So this is simple. And v is equal to, and then we'll say differentiate with respect to x. Okay. Now for v is equal to cos x raised to cot x. Simple it is, right? So if we say log v, it will be cot x log of cos x. And just like similar logarithmic functions, here you'll use multiplication rule and then differentiate. So after you get the answer, you put it in this final equation over here. Okay. So yes, that is question 2 for us. Now let's move on to the next one. question 3. Okay. Question 3. So what is question 3 now? Now these are implicit functions. Find dy by dx they have written. So I'm doing the first one to remember how do we solve implicit functions. Okay. So this is root x plus root y equal to root of a. What do we say? Differentiate on both sides with respect to x. Right? So differentiate with respect to x on both sides. So we have to take derivative of all the terms. Wherever we come across y, we will write it as dy by dx. Okay. So root of x derivative will be 1 upon 2 root of x plus root of y derivative 1 upon 2 root y, okay, into derivative of y dy by dx. And this is a constant term, so derivative is 0. We leave dy by dx term as it is over here, 1 upon 2 root y dy by dx is equal to minus 1 upon 2 root x. Okay. Put 2 root y on the other side, so dy by dx is equal to 2 root y upon 2 root x with a minus sign. So the answer is minus root of y upon x. Simple. Get the dy by dx terms together and then you put in the values, or you separate dy by dx from them, take it common and then find the answer. Okay, this is question 3 first one. And then question 3, the 7th one, the remaining are simple. Just differentiate with respect to x. Wherever you come across y, write dy by dx. Collect all the dy by dx terms together and find the answer. Okay, so keep that on the left hand side, put everything else on the right hand side. Now I'm doing question 3, the 7th one for you. So we have e raised to x plus y equal to cos of x minus y. Okay, so e raised to x plus y cos of x minus y. How will we do this? So we'll say differentiate with respect to x on both sides. Right. So what is derivative of e raised to function? It remains as it is, and we write derivative of the bracket. So that will be 1 plus dy by dx. Okay. Derivative of x plus y will be 1 plus dy by dx. Derivative of cos is minus sine x minus y. Okay. And derivative of x minus y will be 1 minus dy by dx. Simple. So just put the e raised to x plus y inside here. So we get e raised to x plus y plus e raised to x plus y dy by dx equal to minus sine x minus y inside the bracket, minus of minus plus sine x minus y dy by dx. So let us get the dy by dx terms together. We get e raised to x plus y dy by dx minus sine of x minus y dy by dx is equal to minus sine x minus y minus e raised to x plus y. Right? So we take all the dy by dx terms together, put the remaining terms on the right side. Okay. Now take dy by dx common and write the final answer. So final answer dy by dx is equal to, okay, minus sign common, e raised to x plus y plus sine of x minus y, okay, divided by e raised to x plus y minus sine of x minus y. Okay, so this is your dy by dx. Clear? So we've completed up till question 3. All the questions up till here are pretty simple. Okay, what we'll move on to question 4 in question 4, first one, it says show that dy by dx is equal to y by x, right? So what we'll do is we'll take logs on both sides, log on both sides, okay? Since it's power function, so we'll have 7 log x plus 5 log y, right? Is equal to 12 log of x plus y. Powers come down, right? Then we'll say differentiate with respect to x on both sides. Wherever we'll have y, we'll write dy by dx. Okay, so this will be 7 upon x plus 5 log y will be 5 upon y dy by dx. Okay, equal to again 12 as it is, log of function, so 1 upon x plus y, bracket 1 plus dy by dx. Let us open the bracket. So what do we get? 7 upon x plus 5 upon y dy by dx is equal to 12 upon x plus y, open the bracket, plus 12 upon x plus y dy by dx. Correct? We'll take all the dy by dx terms together. So we'll get 7 upon x minus 12 upon x plus y, okay, is equal to 12 upon x plus y minus 5 upon y, and we have dy by dx common. Taking LCMs inside for both left hand side and right hand side, I'll have x plus y here, 7x plus 7y minus 12x equal to y x plus y here and 12y minus 5x minus 5y. Okay, this whole thing multiplied by dy by dx, right? So we are going to get x plus y cancels out on both sides. 7x plus 7y minus 12x, so that is 7y minus 5x, and here also we have 7y minus 5x. So 7y minus 5x upon x, right, is equal to 7y minus 5x upon y multiplied by dy by dx, right? So this cancels out, and we have dy by dx equal to y upon x. Clear? So this is how we get the term equal to y by x. Question 4, first one. In the next session, we will continue with question 4, proving dy by dx equal to y by x. If you have any doubts regarding any of the sums from question 1, 2, and 3, do write to me. I'll give you the solution for the same. Thank you very much.